So in this tutorial, we'll show you how to use the HiVis tool, the basics, and so on. So, so the idea of HiVis is that you can work on spatial transcriptomics data. You can work and do normal analysis in Python, but additionally, the image analysis stuff will be handled in QPath, which is a very good software for image analysis. So the idea is that I used Visium HD, but you can use whichever data you want. It's optimized for you Visium HD, so the import is very easy. If you want to use something else, I will show you how to do it. It's also not very complicated. And the idea is that we have in Visium HD bins, 2x2 or 8x8 small bins. Sorry, 2x2 micron, I meant. And we work on them with Python, while the images themselves, we work in QPath, which has lots of options for image analysis. So in QPath, what we can do is we can do first cell segmentation. So we can use stardist, cell pose, or instance seg in order to create single cells and so on. Additionally, we can do annotations and pixel classifiers. So annotation is just manually annotate something in the tissue, for example, individual objects or tumor and non-tumor and so on. While pixel classifiers is very similar, but it can do it for us. So you just teach the computer with machine learning how something looks in your image, and then it can apply it to the whole slide or even multiple images. So this is very powerful tool. You can segment subcellular compartments, large tissue regions, anatomical structures, and so on. When you have those, you can take all the bins inside such annotation or a single cell, for example, and you can bin them together. You can aggregate all the bins inside. So you will have another layer, which are the objects or aggregation. Those aggregations, you can have multiple of those. For example, in one analysis, you can have one layer that distinguishes tumor and non-tumor area. And also you can have single cells layer and so on. So you can have multiple of those. And then we can pass information from those layers back into the bin level analysis. So for example, if I have a bin that is sitting inside the tumor, the bin itself is now classified as a tumor bin. So now when I work on single cells, I can know is the cell inside the tumor and so on. So this is very important point where you can transfer data between those two layers. Additionally, both the aggregation objects and the bins can be plotted. So there are a few plotting options available. I will show you later. I put a lot of work into this, so the plotting will be very intuitive, very fast and optimized. And also it can produce very nice publication-ready figures. All the figures in my paper are produced with one line of code, pretty much. So it's very nice. They are fully customizable with Matplotlib. Also, you can take the layers and the bins, and you can do built-in analysis, for example, differential gene expression, highly variable genes, correlations, and so on. And lastly, you can use the data inside those layers and bins to do another analysis in ScanPy, GridPy, spatial data, and other tools, because the data is stored in an AData object inside those tools. So now let's go deeper into the individual functions and the objects. So we have the data and image. They can be imported into a new HiVis object. So if you use Visium HD, you can just use the U function in the module. But if you work on another type of data, I have a tutorial in the repo which shows how to import also um, other types of data. You create the HiVis object directly without any function. So if we look at the HiVis object, it has a few methods you can use. So it has general methods such as you can copy it, so you will have multiple copies of those. You can crop and subset it by the XY coordinates or by different metadata, genes. You can subset the genes or the observations. You have a name for the object, which you can rename. You can combine multiple objects into one. You can export the data into undata H5 file, and you can merge end data. So you can take the undata from the HiVis, you can work on it, for example, do a single cell analysis pipeline with ScanPy and so on. Then you can merge it back into the HiVis undata and go back to this. Additionally, you will have some options to work with QPath. I will show you when we will work on the QPath, when I will talk about the QPath area. And if you work on the fluorescent staining, you can recolor, so all the plots will be very nice. Additionally, you can save and load the data as a pickle file. This is very useful, so you don't need to run all the analysis every time. You can just save and load it later. You can export all the data and the images, and you can convert it to special data object. Additionally, you have two methods inside the HiVis method. The first one is analysis. So if you do HiVis.analysis, you will have those 7 analyses. So differential gene expression is to test if which genes are expressed more between two groups or between one group and the rest. Pseudobulk is just average or sum of in groups. Noise mean curve, it can help you to find genes that are variable in your tissue. Correlation can either correlate two or more genes between themselves, or it can find all genes that are correlated to a gene or a gene module. Score genes is from ScanPy. You can take multiple genes and score them. So each bean will have a number that will represent the score of those genes. You can smooth this score or other metadata by different methods, and you can compute distances to the layers that I showed you before, the aggregations. So I will talk about them later, but you can compute the distance of each bin from a certain aggregation object. And lastly, you have different plotting methods. The most important, you have the spatial plot. So here you will have the image, either fluorescence, H&E. You can also do it without the image, of course. And on top of it, you will have the bins colored by whatever you like. You can do a histogram of something. You can plot the correlation and noise mean curve that I showed you in the analysis. And every plot is simply just saved. So every plot here is one line of code, very easy. It has tons of cosmetic arguments inside, which you can check out in the documentation. And also, all of those return an ax object where you can further modify by matplotlib functions. Yeah, so now let's talk about QPath a little bit. So QPath is a software, it's free, it's user-friendly. I highly recommend you using this for image analysis. It supports lots of image data types and channels, and it includes lots of tools inside it. And also, you can automate and script everything inside, so you can reproduce the results very easy. Some of the tools it includes are cell segmentation tools, for example, StarDist, cell pose, and instance egg. You have a very powerful tool, which is the pixel classifiers, where you take the, the tissue and you teach it how something in your tissue looks like, and then it can apply it to your slide and to lots of images. So it can save you a lot of time. You can also do manual annotations and, for example, tumor and non-tumor, and you can do object classifiers. So now let's go into this area of the QPath in our tool. So you can upload the images into QPath, and when you run the scripts in QPath, they can also accept the data in this way. So you can use QPath as is and just do manual annotations or a pixel classifier, and then you can import them into HiVis. I showed you before, there are a few functions in the HiVis that can take those annotations and convert them into the bins. So each bin will know from within which annotation it is located. Additionally, you can use QPath for single cell segmentation, and you aggregate the cells inside QPath. So each bin will know in which cell it is from QPath, but the aggregation of the gene expression data will be done in HiVis. So this is done with the ag cells function. And yeah, so now let's talk a little bit about segmentation, just a side note. So if you are using one channel staining, so this is good for H&E or for DAPI staining, you should use the StarDist. If you have nuclear and cell border staining, you should use cell pose. And if you have more, you should use instance egg, but you can always try all of those to see which one fits your data best. Overall, those tools are great, easy to install, and very powerful. And they also allow you to train a custom model, which is especially good for if you have a tissue that isn't looking like the ones that used to train the default models. So now we have the aggregation object and the HiVis tool. Now, as I said, you can do aggregate cells in order to create the aggregation object, and ag from annotation if you imported annotation directly from QPath and not uploaded the data into the QPath by the Groovy script. So you can transfer data back from the aggregation into the HiVis level by using the sync method. For example, if you have a bin that is inside a T cell, for example, now this data will be available also in HiVis. So you can go into a different aggregation and work on it and so on. So if we focus on the aggregation, similarly to HiVis, we have the analysis. Those are the same analysis, but now done on the objects, not on the bins. We also have plotting functions, which are, again, the same. But you can also plot a UMAP if you did UMAP and latent clustering and so on. And most importantly, you can plot the cells, meaning you will have the outline of the cells themselves. Again, it doesn't have to be cells, it can be objects and so on. But you will have the outline of the cells colored, and also you can fill the cells with gene expression or metadata. You can control, again, everything inside cosmetically, like the alpha, like if you will have the image or not, and so on. Additionally, you have all the methods that I mentioned before with the subset, copy, combine, and so on. And you have the sync method that I talked about. So this is the full diagram of the tool, which I showed you today. So again, we have the data, we create a new HiVis object. We can also create aggregation objects by using GeoJSON files exported from a QPath, or by using a CSV and the GeoJSON, which are exported from the Groovy scripts, which are provided in the repo. So now we will have the aggregation object and the HiVis. Each one of those can be analyzed with those functions here, or exported, just copy the undata, work on it however you like. Then you can use the merge or manually merge the data into the original undata that is stored inside those two. Additionally, we have all the plotting functions, which are highly customizable. And we have the general methods here, which are specific to each one. Overall, this is the diagram, and you can go back to it every time you use the tool, or just print it, and so you will see all the methods that are available. So with this, I thank you for listening to this part. The next part, I will show you how to install the tool and how to run some notebook examples.